Okay, so today I will be doing a video for Portfolio 3. The research question is household chaos predictive of children's problem behavior over and above parenting. So first thing I did was do some assumption testing because it was looking weird and I didn't do it before, and then I realized I should probably check my assumptions first. So a lot of these, well, yeah, almost every single one of them except for chaos was significant, and um, basically that shows that it's like not normal. So then I went further and was looking at things, and see, all of it's really weird. So I found outliers in case 74, 64, and 62, the warmth, SAQ, and then negative parenting. And I went and I Windsorized them. So case 62, I went from 23 to 20 because it was on the opposite side of the scale. Well, no, it was on the higher end. So I did the second highest plus one. And for case 64 for the SDQ, I went from 2.14 to 1.65. The one below it was 1.64, I believe. And then for case 74 for warmth, I Windsorized from 2.67 to 3.32. And that was actually on the lower end, not on the higher end. So it's still the bottom number, but it's just a lot closer than it was. Let's see. And then this, um, a lot of this wasn't significant, and this one was significant. Um, but it kind of just shows the spread of everything. Here's run slow. I've been running a lot of tests over and over. So I ran all those, and after I did all that, I ran the regression test. Oh, I suppose I should show you how I know how to do that. So you'll do regression linear. Put the SDQ up here. The first block, according to Portfolio 3, wanted age and gender in the first block. And then the second block was warmth, anger, positive and negative relationships, and then chaos on the very last one. Went to statistics, did confidence intervals, model fit, R-square change, descriptives, collinearity, diagnostics, Durbin-Watson. Plot, Z was in, Z predict. Down here, produce all, histogram, normality. For the save, I did standardize, unstandardized, standardize, adjusted cooks, and yes. And then I pressed OK. This came out. I deleted the top of the triangle because it's a lot of numbers to look at. There's a lot of negative correlations here, and there's some positive ones. But overall, except for like right here, like that's the strongest it really gets. Let's see. So here's my R squared, my adjusted R squared, my R squared change. This right here, adjusted R squared, shows that model 1 is just not, like, just don't use it because it's not, what's the word? It's just not a good model. There's only, 1.5% here and 3.4% here. So, I mean, that's bigger changes, obviously. Quite a bigger jump from here, which is why that change is bigger. And Model 3 is the better one, but there's also a lot of variables too. So if you look here, this is the usefulness chart basically, and none of them are significant, but this one is more significant than this one greatly, and the F is also a lot bigger than like the first model. Um, and so there's a lot of numbers here. So I wrote it off to the side. Where is it? Oh, no, wait. Here we go. So I simplified this for my report. Um, Really, the only significant numbers was just the negative relationship with the mom, um, which is a lot to look at whenever you look at it here. Um, so yeah, let's see, positive, negative. Okay, 0.003. It's pretty significant. Oh nope, I'm sorry, 0.01. That's significant. 0.03 here is also significant, and the constants, I'm not really sure what this means, but I noticed the constants were significant as well. Um, I'm thinking, Professor said, as long as the t value is greater than the significant, then I can't remember exactly what she said, but like right here, like it's not significant, but the t value is higher, which is good. Um, so I'm not sure what it means. I just remember it. Um, and Cook's distance is good. It's you know not supposed to be above one, and what was that? Durbin Watson is close enough to two. So the data looked really weird before I went through his stuff, and that's the gender, so that's why that looks like that. But it's still kind of funky, and I don't really think any of these are really good models. But if I had to choose, I'd choose Model 3. Um, the only difference is chaos is in there. So let's run through these 5 questions. How much variance? For the final model, it was 3.4. The regression equation, oh, I'm sorry. There was, so for the second question, it's basically is chaos predictive over parenting? I guess is how you would word it. And negative relationship was actually more than chaos. The regression equation for the final model is y equals 0.74 plus zero point zero 0.00 age plus zero point zero 0.01 gender plus zero point zero 0.001 plus zero point zero 0.00 anger plus zero point zero 0.01 positive relationship, basically, plus zero point zero 0.01 negative plus zero point zero 0.05 chaos. And according to that equation, chaos has more leeway in it. There we go. Okay, so if you look right here, this is chaos. This is the negative relationship. It looks like chaos has more, right? But whenever you standardize it, negative relationship is actually more than chaos. Um, it asks, are the residuals good for a good model? And I don't believe it to be. Um, this data set, for the fifth question, this data set violated a lot of the assumptions, like multicollinearity and homogeneity of variance. It was just abnormal. Um, so yeah, there's that. And answer the research question, which was, is household chaos predictive of children's problem behavior over and above parenting? I would say no, overall. Um, I think a negative relationship with the mom is going to, I guess, affect the kid more than actual chaos within the household. Um, so so it's better to have a positive relationship than it is a negative relationship, and chaos doesn't really matter you have a positive relationship, I guess. Is what I'm saying. All right, thank you.